So today I will present about my column design. First, my FYK is 500, FCK is 30, and my CNOM is 20. So, and then we find the loading from the beam and the self weight of the slab at the column itself. And then we find the W. We total up. For first level I got 30.3 to 4.91, 20.251 to 8.2585. For ground floor I get for 3.032, 339, 33.93 to 9.31, 34.38 and then we find bending moment from roof to first level. Main beam I got 335.72 kilonewton per kilonewton meter kilonewton. And then secondary beam I got 33.82. We find the self weight I got 7.073. So we total up we got 74.464 kilonewton. Then first level to ground I got 123.75 for main beam. And then secondary beam I got 91.742 kilonewton. We total up for the first floor is 223.206 and total up of overall is 297.67 kilonewton. Then we find for ground. For ground main beam I get 135.96 kilonewton. Secondary beam I got 100.17 kilonewton. Self weight 3.857. Total up all I got 239.99. Then NAD total overall is 537.66 kilonewton. Then for bending moment at ZZ axis, stiffness is equal to K equal to I over L. And then for beam 4.8768 meter, I got K is equal to 6.4 times 10 power 5. Then 1.524 meter, K I got 2.047 times 10 power 6. Then column roof to first floor, we find the I. So 250 over power 4 over 12 times 3353. The height of roof to first floor of column I got 9.71 times 10 4 mm. First floor to ground floor I got 8.9 times 10 power 4. Ground to foundation 1.7788 times 10 power 5 millimeter square cube. From roof to first floor level, we find the M. I got 20.8183 kilonewton meter, and then 1.851 kilonewton meter. FEM M1 minus F2 I got 18.969 kilonewton meter. So this X is for the formula this one. So I calculate it earlier, so I don't have to manually put the calculation over and over again. So this is X mat my X is 1.34 times to uh, 10 power 6. So and then we find the M for roof. I got 1.279 kilometer meter. First level to ground floor, I got 60.11, 4.82 FEM. And then we find the M upper 3.73 kilometer meter, M lower 3.44 kilometer meter. And then ground to foundation, M we minus FEM, I got 80.9903, M lower 9.47 kilometer meter, M upper I got 5.03. So this is my bending moment. Then for the bending moment at axis, beam, ground floor, this is the same as X at above, and Y is the for ground floor. My ground floor, the length changes, so this is for roof and first floor. This is ground floor. So I need to calculate new one. So 1.15 times 10 power 6 for X, 1.22 times 10 power 6. And then roof to first level, from the M 2.643 to 121.73. And then we find the then for first level to ground floor, we find we got 63.225 minus 5.65, we got 57.58. Then M upper 4.47, M lower 4.124. Ground floor to footing 8.88 minus 52.164. I got 43.98. So include masukkan dalam formula, we got 2.994 kilometer meter. M lower we got 5.602. This is my M moment. Then we need to find the slenderness. My dimension is B times H is 250 times 250. My actual length is Ly equal to 3.658 minus 0.55 equal to 3.1076. Then we find beam, main beam B times H 250 times 550 for LZ1, LZ2, EY1, EY2, column. Then moment of inertia for beam, this is rectangular, so BH cube over 12. Then we find stiffness K to EI over L, KZZ equal to KYY. I got 1.046 times 10 power 5. Beam, main beam. So and then we go to y axis equal to z axis. We find L naught 0.5 L actual, and from this K we masukkan dalam formula ni, and then we got 183.6.31, and then IZZ equal to IYY 48.67, steadiness ratio got T7.73, steadiness limit. We use this formula. My A is 0.7, B 1.1, my C is 0.7, N equal to NED over AC FCD. FCD is 0.85, SCK YC. YC is 1.5, so I got 17 Newton per millimeter square. And then we got N, we got 0.07, we masukkan dalam formula. We got steadiness limit is 20.3366, so steadiness limit is lesser than steadiness ratio. So we got slender on both axis. Then we find moment due to imperfection. M imperfection equal to 537.66 times EI. EI is 20 millimeter. Then we find MEDY, MEDZ. We compare. So my MEDZ is greater. So EZ, we slender check if this one is slender or not. So after we got from the formula, it is slender. So yeah. And then we determining critical moment, MEDZ, MEDY, my H. Then we find beta 1 minus moment over BH FCK. We got 0.7132 greater than 0.3. Then main reinforcement NAD over BH FCK, we got 0.2868. D over H, we got 0.85. M BH square of FCK, we got 0.068. AS FYK over BH FCK. From the table I got 0.05, so my AS required is 0.05 times 250 times 250 times 30 over 500. I got 187.5 millimeter square. So I use 4H8 200 1 millimeter square for my AS provided. Then we find AS minimum, AS max. My AS provided is bigger than AS min, lesser than AS max, so pass. And then we find the meter link. Use the bigger one, so I can use 6 millimeter. My diameter link provided is 8, so pass. Then length spacing, we use the lesser one, 200 millimeter. So my providing spacing is H8 200. And then for the this is my detailing. Right. This one is my detailing. So the spacing between this is 200. I use diameter 8. Then this is H8 300 300 300 300. I think that's it for my column design. Thank you.